But it's just like compared to inductors make sense after.
All right. Okay. So for this one, we're supposed to find VC of t, and it says to plot its waveform. We are not going to plot its waveform because it's not something that you're going to have to do on a test. We'll take a look at the kind of circuit we have. We can see that we have it's going to be a series RLC. And let's find alpha and omega to figure out whether or not we have critically damped, overdamped, or underdamped. And we know for a series RLC, we have that alpha is R over 2L. And omega naught, our resonant frequency, is 1 over the square root of LC. And we will be looking at the circuit after time t equals 0. We have another resistor in there, but that's not the resistor we're looking at. For alpha and omega, we're looking at the resistor in the circuit for the time period after t equals 0. And that this is 1.2 ohms is the resistor, the inductor is 0.1 henries, and the capacitor is 0.4 farads. So alpha is 1.2 over 2 times 0.1, which is 6, and omega naught is 1 over the square root of 0.1 times 0.4, and that is 5. So we have that alpha is greater than omega naught, so that's overdamped. So we'll go and look at our solutions, and for a series overdamped, we need to find, if we look at our solution here, our solution is A1e to the S1t. A1e to the S1t. Plus a 2e to the S2t, or a2e to the S2t, plus VC at infinity, and that is what VC of t is. So to find these things, we need to have S1, and then on that formula page we have that S1 is minus alpha plus the square root of alpha squared minus omega naught squared. We'll need S2, and S2 is minus alpha minus the square root of alpha squared minus omega naught squared. And for A1 and A2, we're also going to need to find, I'll write those formulas when we get to them. We'll need IC of 0, we'll need VC of 0, and we will need VC at infinity. So those are all things that we're going to need. So let's start by finding these values at 0. So at 0 minus, our circuit looks like this. Our inductor is a short circuit, and our capacitor is an open circuit. and our capacitor is in parallel with this resistor. We have a current that's going through here, and for that current, we have that our voltage is 12, and our total resistance is 0.4 plus 1.2 is 1.6. So that's V equals IR. So I is 12 over 1.6, or I don't think I wrote it down. I didn't write it down.
7.5.
7.5? Okay, so then the voltage across this resistor right here, so the voltage across this resistor, the 1.2 resistor, equals the voltage across the capacitor. So VC at 0 equals 7.5 times 1.2, because the voltage across the resistor is IR, and so that's 9. So VC of 0 is 9. Okay, let's see. Now we need to look at time 0 to get IC of 0. So at 0, we open the switch. Now, I did not write it down, but I should have. What was IL of 0? 0. Okay, so if IL of 0 is 0, then now that means that at 0, we still have 9 volts here, and we still have 0 amps here. Those can't change. So if this is 9 volts and that's 0 amps, what does the current through the capacitor have to be?
So this is, you said this is 9 volts here.
Mm-hmm.
This is how many Henry?
It is 0.1 henries, but right now what I'm saying is that it has 0 amps. The current is 0 amps.
Where?
Through the inductor.
Through the inductor?
Because it was 0 at 0. There was 0 current here, so there has to be 0 current here.
Okay.
Because the voltage through the capacitor and the current through the inductor can't change. So knowing that we have 0 amps through the inductor, that means we also have to have 0 amps through the capacitor.
Okay.
Seems weird, but that's this we cannot change. We cannot change that that's 0 amps.
Okay.
And if that's 0 amps, then it's 0 amps for everything that's in series with it.
Okay.
So IC of 0 is 0. Now, how about IC at infinity? I'm not going to redraw it, but just know, well, I'll redraw it. So at infinity, we have this, and I'm sorry, I want VC at infinity. So VC at infinity. So what's that going to be?
0.
Yeah, it's going to be 0, because the energy that it had, it was charged to 9 volts.
Mm-hmm.
That's going to discharge
Mm-hmm.
through the resistor, and at infinity we'll have 0. Okay, so now we have IC of 0 is 0.
Would IC at infinity be 0?
0. VC of 0 was 9, and VC at infinity is 0.
So with the no current that you were saying?
Yes? That's the hardest part to see. And to keep track what's the most important thing. Because if you don't realize that that's the most important thing, then you might try to do Ohm's law with your voltage here and your resistor here. But that's not the most important thing, is that this has to be 0 amps and this has to be 9 volts.
Okay, that makes sense, I guess.
It doesn't, but it's that's how it works. To me, it doesn't. To me, I've just accept it.
Oh, so is discharging is 9 volts?
It will, yes. Just right now, there's no current yet. In a split second, there's going to start being some current.
And it's the capacitor discharging is 9 volts is what creates that split second current.
Yes.
Okay.
And then it will continue. Well, depending on what did we have here, we had an overdamped, so it'll follow a certain path until it goes down to 0. Okay, so now let's get our S1 and S2. So S1 is minus alpha, and alpha was 6. So it's minus 6 plus the square root of 36 minus 25. And so S1 ends up being negative 2.68. And S2 is minus 6 minus the square root of 36 minus 25, and that's minus 9.317. And then from our solutions, we have that A1 equals 1 over C IC of 0 minus S2 VC of 0 minus VC at infinity over S1 minus S2. And we have that A2 equals 1 over C IC of 0 minus S1 VC at 0 minus VC at infinity over S2 minus S1. Okay, so this is where I was saying at this point, it's just a lot of plugging in numbers, but IC of 0 was 0. So this is 0. VC at infinity is 0. So we end up with A1, we have minus S2. S2 was negative 9.37, so that becomes positive 9.317 times VC of 0 was 9 over S1, negative 9.317 minus S2, so plus 2.68, and A1 ends up being 12.64. And A2 minus S1 is 2.68 times VC of 0 is 9 over S2 negative 9.317 minus, that becomes plus 2.68, and A2 becomes negative 3.634.
This is honestly like not that bad. It's really just
It's
figuring
not.
out the values.
Most people don't find it that bad at all. It's because it's just it's not fun. I don't up to this point I'm okay with it. This part I don't like all these numbers. Okay, so then I wrote it up here what VC of t was. So now we can say that VC of t is 12.64 e to the minus 2.68t plus A2 is negative 3.634, so I'm going to say minus 3.634 e to the negative 9.317t, and then plus v at infinity was 0. So that's your final answer.